Hey, what's up guys? Welcome back to another video in the Java series. In this video, I'll be teaching you about a new Java 22 feature, which is unnamed variables and unnamed patterns. Hopefully it sounds okay. This is a new microphone I'm testing right now. So let me know how you think it sounds. I'm going to try and make it... I'm always struggling with my audio, but hopefully it sounds decent now. But yeah, welcome back everybody. So Java 22 just came out last week at the time of recording here, but the biggest one that I see is unnamed variables and unnamed patterns. Now this video is going to require that you know about another feature from Java 21, which is record patterns, okay, and also how to do records in general, which is a Java 16 feature. So just make sure you watch those two videos. I'll link them down in the description below so you can check them out. You just need to know how to create records, what they are, and then also how to do record patterns, okay? But if you're familiar with those things, then this video will be pretty interesting for you. So I think it'll be best here if I just give you some examples of what unnamed variables are and how they're useful. So we're just going to make some simple code here that will go through that list and just count how many names there are. Of course, I could just do names.size, but that's not the point here. So we're going to do int count is equal to 0. And then we're going to go ahead and loop through these names. So we're going to say for names or var name names. So it's just a simple enhanced for loop. And then for each name in the list, we want to do count plus plus. And then we'll also just send a message saying I'm doing some stuff. So this is a very basic example here, but this is a good example of a situation where you're going through a list of something or an array of something, and you're running some code for each item in that list. And you don't really care about the name itself. You don't really care about each item in the list. You just want to do something for each of those items, and that's what we call a side effect. So with unnamed variables, we can just actually ignore the name of this by doing that. So with this underscore here, we are now just telling Java that we don't really care about the name variable, have it as a placeholder so that we can run some code for each item in the list here, right? And of course we're using var, but you can specify the type if you want to. So like, string underscore, that's still going to be an unnamed variable. So this makes our code a little more concise, I feel like. We're not really wasting space declaring names for something that we don't really need or care about. Again, this is a very basic example here, but I think it helps overall making your code more maintainable, more readable. So we could also specify the type if you want to instead of using var. That's really up to you, but var is commonly used nowadays for enhanced for loops. So let me give you some more examples here where this is useful. And by the way, we can go ahead and do count, just print the count like that. But another example here is for try with resources. I think this is actually a really good example here because I've done some SQL recently. So when you use something like JDBC, Java Database Connectivity API for connecting to databases, you may often do something like this. So connection is equal to driver manager dot get connection, and then you put your database information here, so localhost, user, password, something like that, right? And then of course let's fix that. That's the type of what we have, and then we can go ahead and open that up, and then we'll just add a catch on the end of that because we have to. So this will be an SQL exception, and then for the exception we can just blah blah blah, DB broke. Okay, so this is a pretty common pattern when you're working with JDBC. You often will need a connection to the database, so you're going to establish one. And so since we're using try with resources, whenever this is done, it should automatically get rid of that connection for you. And also if an exception happens, it should handle that for you. So this is a really nice way of working with that, right? So even though we have this connection here, we don't always want to use it. Sometimes we don't even care about it. We just want to establish the connection, then do something. So whenever that situation happens, you can again use an unnamed variable just by using underscore. So an underscore is just how you make it unnamed. So now we don't really care about the connection itself. We just want to go ahead and establish the connection and then go ahead and run some other code after that. So again, an unnamed variable is kind of just like a placeholder when you really don't care about the name of the variable because you're not even going to use the variable. So this is another similar example here. So if we have an exception, we could do something like try, and let's say an exception is thrown in our program. So we'll do an exception throwing manually. So something went wrong. Okay, so an exception is being thrown, so now we need to catch it, right? So we can do catch and exception. EX is what is commonly named, I think, or E or EX, whatever you want to call it. And then inside of here, to handle the exception, we can run whatever code we want. And I find that often you don't even use the exception object itself, like EX. Sometimes you'll use it to get information about, the stack trace or whatever, or about the exception in general, but not always. Sometimes you don't even care. You just want to run some code to handle the exception properly, like maybe close the connection to the database or something like that, right? So in this case, you could again make this unnamed as well. So the variable is required for this, but we don't really care about it, so we'll just make it unnamed. So the variable's there technically, but we don't really care about it. It's just going to sit there unnamed, and then we can run whatever code we want inside of here to handle our exceptions for our program, okay? And then one more example, and there's plenty of examples I can give you here. There's like a billion things you could do. I'm just giving you some basic ones here. One more just quick one is if, I'm doing a lambda, and even for like a simple for each, we want to, print something out for each of the names in our name list. Before, we could do something like name and then arrow and then S out, and then we're just going to say beep. So in this case, we're running some code for each of the names in the list like we did, for this first example here. But we don't really care about the name itself. So since we're not actually using the name variable, we can make it unnamed by just giving it the underscore. So now our code is a little more concise. Okay, so now let's move on to something called unnamed patterns, and this is for record patterns, which is a feature I told you about when I started this video. This is just a way of destructuring records to get the values from records. So this is some sample code from JetBrains. I'll link it in the description below. It's a pretty interesting blog on this feature here. So we just have an interface, and then we have 4 different records that implement that interface. So they're all technically from the same type, from the same interface type, which is pretty cool. And so now we can use those records as we wish. So if we're going to make a new object, point A, from our point record, so new point, and now we need a x and y value, so we're going to say something like 0 and 567. There we go. Now we can use a record pattern here by doing if point A is a instance of point, and then we could say, int x and int y. Then we can go ahead and use those variables, so we could say s out, point A is at x, like that. And then we could also do the same thing for y if we want to. So this is a simple record pattern. This is not an unnamed pattern. So we're simply taking this object of this record type, checking to see if this object is a type of point. If it is, then also destructure it and give us these 2 variables that we can use inside of the code block here, x and y, which are integers, and use them, right? But let's say that you only want x and you don't even want to use y, which is just a simple way of representing that, whatever code that you have inside of this code block here, it doesn't even use the y variable for some reason, right? So what you could do is take this entire thing and just actually delete it and replace it with an underscore, just like how we did above with the unnamed variables. So what makes this an unnamed pattern is just simply because we're using it inside of a record pattern, and also because we're replacing the entire thing, the data type and the variable name, with an underscore. So that's how you can sort of distinguish between the 2 types of patterns that we have here. So now if we don't want to use x, so now in situations where you don't even want to use a variable or multiple variables, you simply replace it with an underscore so that it's not taking up space needlessly, and you're not declaring variables that shouldn't actually exist. So it's still important, of course, that you have it there just because, as a placeholder, because point has 2 variables within it, as we declared up above here. So it has x and y. So to actually match the pattern, using instance of, you have to have the correct number of fields for that pattern. So that's a very basic example. Let me give you another one, a little more complex one, using a nested record pattern. So we're going to have a new line that's going to have a point or 2 points within it. Let me just zoom in a little bit for you guys. So it's going to have like 5 and 6. And then for the second point, we're going to have 78 and 4, something like that, right? And so now we will do our nested record pattern. So line, instance of line, and then within that we could do point. So we know that point has int x1 and int y1, and then after that first point we could add the second point if we want to, and we could do int x2 and int y2. So that's the nested record pattern, just because we have a record pattern within another record pattern. And so now we can use these x and y variables directly from both of these points. So we could do something like point A starts at, blah, 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 right? Whatever you want to do there. But let's just say that you don't want to use all parts of this, just like above. We only use part of it. So let's just say that we only want to print out where the second line starts, right? So we could say something like line ends at x, and then we do x like that. Well, it would be x2 in this case, since that's the name of the variable here. So in this case, we're only using x2, so we don't actually need to destructure this first point here using a record pattern, right? So we could replace this entire thing with an underscore. The alternative to that before this feature was introduced was just to do like something like var, and then just give it a random name like point A or something like that, whatever you want to call it. And it's just complaining because there's already a point A, but you get the point, right? Get it? Point? Haha. Anyway, so you could just replace this entire thing with an underscore now, which makes it a lot more concise and simplified. That's the whole point of this feature, I think, just to make it more simplified. And then for the second one here, only part of this is being used. So what you could do is just, use an unnamed pattern for the part that you don't need. So in this case, we don't need int y2, so we just replace that part with an underscore. So now here we're still using our record patterns, except that the parts that we're not using is replaced with an underscore where it's necessary. I think that's a pretty cool feature, if I say so myself. I just want to give you guys a more advanced example real quick using a switch statement, because those are pretty useful and they can be used with record patterns if you're familiar with them. So let me copy some code and I'll be right back. So again, this code was provided by the same source as these records up here, from the JetBrains blog I told you about, so make sure to check it out in the description below. But yeah, so now we have this calculate area method, and this is going to take in a geometric shape, which is the interface that we defined above, and then all of these different types of geometric shapes implements geometric shape. So all that simply means is that this method here can accept any of those types, any of those record types. So within the switch expression that we have here, we can do switch, figure, and then we can match it using pattern matching, or record pattern specifically, to determine which specific record type it is. So in this case, we're checking figure, and the first thing it'll check to see is say, okay, is figure a point, and does it have int x and int y within that value? If it does, then it will just return 0. We don't really have an area for a point, it's just a point. And then if it's not that, it'll go to line, of course, and check line. So if it's a line and has point A and point B, do 0, because line has no area as well. And then if it's a triangle, it'll also do the pattern matching here, and then it'll do area triangle. So I think this is pretty cool, right? But something you may have noticed is that we're not using all parts of these record patterns that we have here, right? So this is a very good use case for our unnamed patterns that we just learned about. So in this case, what we could do is, replace any of the parts here that we're not using. So we could start with this. We're not using X, and then of course we're also not using Y, so we'll replace that one. So we simplify this a little bit just by removing int x and int y and just replacing them with underscores using unnamed patterns. Same thing for this one here. We're not using point A or point B, so we can replace those as well. And then for these last two here, we're actually using all of these, so we don't really need to touch them. We don't need to mess with them at all. They're good how they are. But if for some reason we weren't using one of these, you could again, just replace it. Same as before, okay? So because at this point they're both underscores, there's not really a point in actually doing the record pattern here. So it would be the same thing as just taking this and just naming it as a regular variable, like Bob, for example, or point A, or whatever you want to call it. But again, we don't need Bob, so we could replace Bob with an underscore as well. So now we've turned it from an unnamed pattern to an unnamed variable, just like we have above. So with our unnamed variables that we had before, we do something like var underscore, so the type, and then the variable name, which is an underscore. And so we did the same thing here. We're doing point and then underscore, because we need to have the type still, right? Because we're doing, a switch expression. We need to match it to the type that it's part of, but we don't really care about the name. We're not actually using the variable, so we could just use an underscore if we want to. Same thing for here. For line, all of the fields of the record are not being used. They're all replaced with unnamed patterns. So we could replace this entire thing with an underscore, so now it becomes an unnamed variable. So hopefully that makes sense. I think that's pretty cool. And then of course with the magic of switch expressions, you could simplify this even more, because these both return the same value. So you could just, take this and do like comma, boom, and there we go. So now this is much more simplified than before, and it uses unnamed variables. And that's pretty much all I want to show you guys for this episode. Hopefully you found this interesting. This was unnamed variables and unnamed patterns. This is a Java 22 feature, but you may be watching this at a point when there's a newer version of Java, so you can still use this feature, of course. But if you're using a Java version below 22, you cannot use this feature. So just make sure you upgrade your Java version and you'll be good. Now you can use unnamed variables in situations where you don't really need the variable. Well, you need the variable to be there, but you don't really care about using it, so you just replace it with a little placeholder, which is an underscore. That's an unnamed variable. And then in situations where you're doing record patterns, to do pattern matching with records, you can use unnamed patterns when you don't need certain parts of a record pattern, okay? So that's pretty much it. Thanks for watching, everybody. Hopefully you found this video interesting, and I'll see you guys again next time. Thanks for watching, everybody. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.